Rebar Detailing Industry and Workflow. Career Horizons, Global Workflows, and Detailing Standards. Hello everyone, and welcome back to Rebar 360. In our previous lessons, we learned the fundamentals of reinforced concrete, the basics of rebar detailing, and the role of a rebar detailer. Today, we're going to look at the bigger picture. Many beginners know how to prepare drawings, but they don't fully understand how the entire rebar detailing industry works. They often ask questions like, who uses my shop drawings? What happens after I finish the BBS? How is rebar fabricated? What career opportunities are available? And how does rebar detailing differ across countries? In this lesson, we'll answer all of these questions. We'll explore the evolution of rebar detailing, from manual drafting to modern BIM technology. We'll understand the stakeholders involved in every project and see how architects, structural engineers, detailers, fabrication yards, and construction teams work together. We'll also compare detailing standards used in India, the Gulf, the UK, the USA, and Canada, and understand why different countries follow different codes and software. Most importantly, we'll study the complete detailing workflow, starting from reviewing structural drawings all the way to fabrication, site installation, inspection, and concrete placement. Finally, we'll discuss the career path available in rebar detailing and how you can grow from a trainee to a team leader and beyond. This lesson is especially important because it helps you understand where your work fits into the overall construction process. Once you understand the complete workflow, you'll no longer think like a CAD operator. You'll start thinking like a professional rebar detailer. So let's get started with a quick recap of what we've learned so far. Professional tip. Don't focus only on preparing drawings. The best rebar detailers understand the complete life cycle of reinforcement, from design to fabrication to installation. That broader understanding makes you far more valuable to any organization. Detailing evolution. Rebar detailing has evolved significantly over the last few decades. The tools have changed, the workflows have improved, and the expectations for accuracy have become much higher. Let's look at this evolution. 1. Manual drafting, the beginning. Before computers became common, rebar detailing was done entirely by hand. Detailers used drawing boards, T-squares, scales, and ink pens to prepare reinforcement drawings. Bar lengths, bending dimensions, and quantities were calculated manually. Although skilled detailers produced excellent drawings, the process was slow, time-consuming, and more prone to calculation errors. Making revisions often meant redrawing large portions of the drawing. 2. 2D CAD, the digital revolution. The introduction of computer-aided design, CAD, transformed the industry. Software like AutoCAD allowed detailers to prepare drawings much faster and with greater precision. Editing, copying, and revising drawings became much easier. However, traditional 2D CAD still required detailers to manually coordinate drawings and prepare bar bending schedules. If a drawing changed, the BBS often had to be updated separately, increasing the risk of inconsistencies. 3. 3D BIM, the modern standard. Today, the industry is rapidly moving toward building information modeling, or BIM. Instead of drawing reinforcement in 2 dimensions, detailers create a complete 3D digital model of the structure. Every reinforcement bar exists as an intelligent object with its own size, shape, length, and properties. One of the biggest advantages of BIM is coordination. Different disciplines, such as structural, architectural, and MEP, can work together within the same model. Potential clashes are identified before construction begins, reducing costly site modifications. Another major benefit is automation. Shop drawings, bar bending schedules, quantities, and reports can often be generated directly from the model, improving both accuracy and productivity. The technology has changed, but one thing remains the same. Whether you're using a drawing board, AutoCAD, or BIM software, the success of a rebar detailer still depends on understanding structural drawings, following standards, and paying attention to detail. Software is simply a tool. Engineering knowledge is what makes the difference. Professional tip: don't rely only on software. AutoCAD, Revit, or Tekla can improve your productivity, but they cannot replace engineering judgment. A skilled detailer understands the structure first and uses software as a tool to communicate that understanding. Construction stakeholders. Every successful construction project is the result of teamwork. Rebar detailing is not an isolated activity, it connects several professionals and organizations throughout the project lifecycle. Let's understand the key stakeholders and their responsibilities. 1. Design office. The process begins in the design office. This includes architects, structural engineers, and design drafters. The architect develops the building layout, while the structural engineer designs the structural system and specifies the required reinforcement. These design drawings become the foundation for all detailing work. As a rebar detailer, your first responsibility is to understand these drawings thoroughly before preparing shop drawings. 2. Detailing hub. The next stage is the detailing hub, where rebar detailers transform engineering designs into practical construction documents. Using the structural drawings, project specifications, and applicable standards, the detailer prepares reinforcement shop drawings, bar bending schedules, BBS, bar marks, reinforcement details, construction notes. At this stage, the detailer also identifies drawing discrepancies, coordinates with engineers, and raises RFIs whenever clarification is required. In simple terms, the detailing hub converts engineering concepts into fabrication-ready information. 3. Fabrication yard. Once the shop drawings and BBS are approved, they are sent to the fabrication yard. Using the BBS, the fabrication team cuts reinforcement bars, bends them into the required shapes, bundles and tags them, organizes them for delivery to the site. The accuracy of fabrication depends entirely on the quality of the shop drawings and the BBS prepared by the detailer. 4. General contractor and site team. The final stage is the construction site. The general contractor manages the execution of the project. Site engineers inspect the reinforcement, while steel fixers install the bars according to the approved shop drawings. After inspection and approval, concrete is poured, completing the reinforcement cycle. Notice how every stakeholder depends on the previous one. If the design contains errors, the detailer is affected. If the detailing is inaccurate, fabrication suffers. If fabrication is incorrect, the site experiences delays and costly rework. This is why communication and coordination are just as important as technical skills. Always remember, a successful project is built through teamwork, and the rebar detailer is one of the most important links in that chain. Professional tip. One of the qualities of an excellent rebar detailer is effective communication. Don't hesitate to coordinate with structural engineers, architects, fabricators, or site engineers when something is unclear. Asking the right question at the right time can prevent major construction issues later. Global detailing standards. As the construction industry becomes more global, rebar detailers have opportunities to work on projects across different countries. However, one important thing to remember is that every region follows its own standards, drawing practices, and software. Let's compare some of the major regions. India. In India, projects generally follow IS 2502 and IS 13920 for reinforcement detailing and seismic requirements. Drawings use metric units, and bar bending schedules are commonly prepared in Excel or detailing software like CAD's RC and AutoCAD. Gulf countries and UAE. Many projects in the Gulf follow BS 8666, the British standard for scheduling, dimensioning, bending, and cutting reinforcement. Like India, drawings use metric units, but BBS formats often follow BS standards and may include SDI formats depending on the project. This is one of the reasons why professionals with BS detailing knowledge are in high demand across the Middle East. USA and Canada. In North America, detailing is based on ACI 315 and CRSI guidelines. One major difference is the use of imperial units, such as inches and feet, instead of millimeters. The bar bending schedule is often included directly on the shop drawings or generated using software-specific formats like ASA bar list. Common software used. Although standards differ, modern detailing relies on specialized software. Some commonly used applications include RGS Rebar, supports Indian, Gulf, UK, USA, and Canadian standards. Rebar Plus, popular for India, Gulf, and UK projects. Armor and Steel Pack, used in fabrication yards for production planning, tagging, and logistics. Revit, BIM software for architectural, structural, MEP, and rebar modeling. Tekla structures, widely used for structural steel, precast, and advanced rebar detailing. The software may change from one company to another, but the fundamentals of rebar detailing remain exactly the same. A professional detailer can adapt to any software because they understand the engineering principles behind the drawings. Remember, learn the concepts first. Learning new software becomes much easier afterwards. Professional tip. Many beginners ask me, which software should I learn? My answer is always the same: learn rebar detailing first, then learn the software. Companies can train you on new software in a few weeks, but developing strong detailing knowledge takes time and experience. That knowledge will stay with you throughout your career, regardless of the software you use. Detailing Workflow, Part 1. Now let's understand the actual workflow of a rebar detailing project. Many beginners think detailing starts by opening AutoCAD and drawing reinforcement. In reality, professional detailing begins much earlier, with understanding the project. Let's go through the first 3 steps. Step 1. Structural Drawings Review. The first and most important input for every rebar detailer is the structural drawing. Before drawing a single reinforcement bar, carefully study General Arrangement (GA) drawings, Plans and Sections, Reinforcement Notes, General Notes, Project Specifications. The objective is to understand the engineer's design intent, member sizes, reinforcement requirements, and construction sequence. A detailer who understands the drawings makes fewer mistakes and asks better questions. Step 2. Review reference drawings. Structural drawings alone are not enough. Professional detailers also review architectural drawings, MEP drawings, civil drawings, landscape drawings. Why? Because these drawings contain information that can affect reinforcement detailing. For example, lift and stair openings, pipe sleeves, electrical conduits, embedded plates, level differences. Identifying these details early helps prevent clashes and reduces costly revisions during construction. Step 3. Prepare rebar shop drawings. Once all drawings have been reviewed, the detailing work begins. The shop drawings are prepared based on structural design drawings, project specifications, applicable detailing standards, approved project revisions. The drawing should clearly show reinforcement layout, bar marks, bar diameters, bar spacing, lap lengths, anchorage details, sections and construction notes. The goal is simple. The fabrication yard should know exactly what to manufacture, and the site team should know exactly how to place the reinforcement. A well-prepared shop drawing eliminates guesswork and minimizes errors during construction. Remember, the quality of construction depends heavily on the quality of the shop drawings. That's why professional detailers spend more time understanding the project than simply drafting it. Professional tip. One of the biggest mistakes beginners make is starting detailing immediately after opening the structural drawing. Spend time reviewing all project documents first. A thorough review at the beginning can save hours of revisions later. Detailing workflow, Part 2. Once the shop drawings are completed, the next stage is preparing the bar bending schedule, or BBS, and obtaining approval before fabrication begins. Let's look at these important steps. Step 4. Prepare the bar bending schedule, BBS. The BBS is generated from the approved shop drawings. It is one of the most important documents in rebar detailing because the fabrication yard uses it to manufacture the reinforcement. A typical BBS includes bar mark, a unique identification number for each bar. Bar diameter, the size of the reinforcement. Shape code, the standard bending shape. Cutting length, the exact length before bending. Quantity, number of bars required. Total weight, steel quantity for fabrication and procurement. Every item in the BBS must match the shop drawings exactly. Even a small error in bar length or quantity can lead to incorrect fabrication and unnecessary material wastage. Step 5. Consultant/engineer approval. Before reinforcement can be fabricated, the shop drawings and the BBS are submitted to the consultant or structural engineer for review. During this stage, the consultant checks compliance with structural drawings, reinforcement arrangement, bar sizes and spacing, lap lengths and anchorage, constructability, compliance with project specifications. After the review, one of three things usually happens. Approved, the drawings can proceed to fabrication. Approved with comments, minor corrections are required before use. Rejected, significant revisions are needed, and the drawings must be resubmitted. As a rebar detailer, you should treat review comments as an opportunity to improve the quality of your work. Remember, the goal is not just to get approval, it is to ensure the reinforcement is safe, accurate, and buildable. A carefully prepared drawing usually receives fewer comments and moves through the approval process much faster. That's why checking your own work before submission is one of the best habits you can develop as a professional detailer. Professional tip. Before submitting any shop drawing, compare it with the BBS one final time. Ensure every bar mark, shape code, quantity, and cutting length matches perfectly. A few minutes of self-checking can save days of revisions and prevent costly fabrication errors. Detailing workflow, Part 3. Once the shop drawings and bar bending schedule have been approved, the project moves from the detailing office to the fabrication yard. This is where the reinforcement shown on the drawings becomes real steel bars ready for construction. Let's go through the next 3 steps. Step 6. Rebar fabrication. The fabrication yard uses the approved BBS to manufacture the reinforcement. Each bar is cut to the required length, bent according to the specified shape code, checked for accuracy, tagged with its bar mark. Modern fabrication yards use automated cutting and bending machines, which improve accuracy and productivity. However, these machines are only as accurate as the BBS they receive. That's why a correct BBS is essential. Step 7. Pre-assembly of reinforcement cages. For many large projects, reinforcement is partially or fully assembled in the fabrication yard before being transported to site. Typical examples include column cages, beam cages, pile cages, pile caps, shear walls, precast concrete elements. Pre-assembly offers several advantages: better quality control, faster installation on site, reduced labor at the construction site, improved safety and productivity. Not every project requires pre-assembly, but it is widely used on large commercial and infrastructure projects. Step 8. Transportation to site. Once fabrication is complete, the reinforcement is bundled and prepared for delivery. Each bundle is clearly tagged so that the site team can easily identify and install the correct bars. Proper loading and transportation are also important. Poor handling can damage reinforcement, especially epoxy-coated bars, or create confusion if bundles are mixed. Good logistics ensure that the right reinforcement reaches the right location at the right time, helping construction progress smoothly. At this stage, the responsibility shifts from the fabrication yard to the construction site. The quality of installation now depends on how accurately the reinforcement has been detailed, fabricated, and delivered. Every stage in this workflow is connected, and success depends on teamwork and accurate information. Professional tip: whenever possible, visit a fabrication yard. Seeing how reinforcement is cut, bent, bundled, and tagged will greatly improve your detailing skills. Once you understand the fabrication process, you'll naturally prepare more practical and fabrication-friendly shop drawings. Detailing Workflow, Part 4. Now we've reached the final stage of the rebar detailing workflow, the construction site. At this point, the shop drawings and bar bending schedule have already been approved, the reinforcement has been fabricated, and the steel has arrived on site. Let's look at the final 3 steps. Step 9: Rebar Installation at Site. The first activity is placing the reinforcement according to the approved shop drawings. Steel fixers install each bar in its correct position, ensuring that bar marks match the drawings. Concrete cover is maintained using cover blocks. Chairs and spacers support the reinforcement. Couplers and lap splices are installed correctly. Reinforcement remains stable during concrete pouring. Proper installation is just as important as proper detailing. Even perfectly fabricated reinforcement can fail to perform if it is placed incorrectly. Step 10: Inspection and Approval. Before concrete is poured, the reinforcement must be inspected. The inspection is carried out by the site engineer, QA/QC team, and often the consultant or client's representative. During the inspection, they verify bar sizes and spacing, concrete cover, lap lengths and anchorage, reinforcement positions, compliance with approved shop drawings. If any discrepancies are found, they are corrected before moving to the next stage. This inspection ensures that the reinforcement has been installed exactly as designed. Step 11: Concrete Placement. Once the reinforcement is approved, concrete placement begins. During concreting, it's important to ensure that the reinforcement does not move from its intended position. The site team carefully places and vibrates the concrete while protecting the reinforcement arrangement. After the concrete hardens, the reinforcement becomes permanently embedded within the structure, working together with the concrete to safely carry structural loads. This completes the entire rebar detailing workflow. Notice how every stage depends on the previous one. A mistake made during detailing can affect fabrication. A fabrication error can delay installation. An installation mistake can delay concrete pouring. That's why every rebar detailer plays a critical role in the success of a construction project. Remember, good detailing leads to smooth fabrication, efficient installation, and high-quality construction. Professional tip: whenever you have the opportunity, visit a construction site after your shop drawings have been issued. Seeing how reinforcement is installed will help you understand practical challenges and improve the quality of your future detailing. The best detailers are those who regularly connect office work with real site experience. Career Growth Path. As we come to the end of this lesson, let's talk about something that motivates every learner: career growth. One of the biggest advantages of choosing rebar detailing as a profession is the clear career path it offers. With the right skills, experience, and continuous learning, you can steadily grow into leadership positions. Let's look at the typical career progression. Step 1: Trainee Detailer. Every professional starts as a trainee. At this stage, your focus is on learning the basics. Reading structural drawings. Understanding reinforcement concepts. Learning detailing standards. Using CAD or BIM software. This is the stage where you build a strong foundation. Step 2: Junior Draftsman. As your confidence grows, you'll begin preparing simple shop drawings under the guidance of senior detailers. You'll learn to detail basic structural elements. Prepare bar bending schedules. Apply company standards. Develop speed and accuracy. This is where practical experience begins. Step 3, Detailer/BIM Modeler. After gaining experience, you'll independently handle complete projects. Your responsibilities include preparing shop drawings, creating BBS, coordinating with engineers, managing revisions, performing quality checks. If you're working in BIM, you'll also create intelligent 3D reinforcement models using software such as Revit or Tekla. Step 4, Detailing Checker. The next step is becoming a checker. Instead of preparing drawings, your primary responsibility is to review and verify the work prepared by other detailers. You'll identify errors, ensure compliance with standards, and maintain the quality of project deliverables. Step 5, Team Leader. The highest stage shown here is the team leader. A team leader manages projects, guides detailers, coordinates with clients and engineers, plans resources, and ensures projects are delivered on time with the required quality. Leadership requires more than technical knowledge. It requires communication, planning, decision-making, and mentoring skills. Your career doesn't stop here. Many experienced professionals continue to become project managers, BIM managers, engineering managers, or even start their own detailing companies. Remember, your growth is determined not only by your experience but also by your willingness to keep learning. Every project you complete is an opportunity to improve your knowledge and move one step closer to your career goals. Professional tip: don't measure your career by the number of years you've worked. Measure it by the number of projects you've learned from. Every drawing you prepare, every mistake you correct, and every challenge you solve makes you a stronger rebar detailing professional. Congratulations! You've successfully completed another lesson in our BS Rebar Detailing course. In today's session, we explored the complete rebar detailing industry and workflow. We learned how the industry has evolved from manual drafting to modern BIM technology, understood the roles of different stakeholders, compared international detailing standards, and followed the entire workflow, from structural drawings to fabrication, site installation, inspection, and finally concrete placement. Most importantly, we discussed the exciting career opportunities available in rebar detailing and the skills required to grow from a trainee to a leadership position. I hope this lesson has given you a clear understanding that rebar detailing is much more than preparing drawings. It is a profession that combines engineering knowledge, communication, coordination, and problem-solving to ensure successful construction projects. If you're serious about building a successful career in this field, my advice is simple. Keep learning. Practice regularly. Study real project drawings. Visit fabrication yards and construction sites whenever possible. The more you understand the complete construction process, the more valuable you'll become as a rebar detailer. In our next lesson, we'll continue building on these fundamentals and move into more practical aspects of rebar detailing based on BS 8666. If you found this video helpful, please support Rebar 360 by clicking the like button, subscribe to the channel, and share this video with your friends and colleagues. I'd also like to hear from you. Which part of the rebar detailing workflow would you like to learn in more detail? Let me know in the comments below. Your suggestions help me create videos that are practical and useful for your career. Thank you once again for watching. I'm looking forward to seeing you in the next lesson. Until then, happy learning and happy detailing.